So now we have a design. This is great. How do we take that design and turn it into code? So now we're going to take a look at syntax in Python. And we're going to take a look at a general form of syntax. And I'll explain what it means in a moment. Okay. So class definitions have the following form. Okay. So how do we read this? Anytime you see something with these little angle brackets, like you'd have in HTML or XML, what this means is this is a type of statement, a type of value that can be replaced. Right? So class is literally what you put in. The very first word is class. And then you're going to replace the phrase name with the name of your object. Whatever you want to name your class, right? And the type of object you want to create, that goes there, right? So, credit card. Cool. When you see the square brackets, this means that it is optional. You do not use the brackets, just like you don't use the angle brackets, but it says that anything within these square brackets is optional. You do not need to include it. Okay. So we can skip it and we can just put our colon. Now, if we wanted to, we could add our parentheses and then the name of whatever we wanted to inherit from. And we will later on. We will later on do this when we are taking a look at inheritance and how to implement that in Python. So that's what would go there. We're going to skip it because we're not inheriting from anything. Okay. Then we go constructor, and then we go method declaration, and then we got a star here. Okay. This star is called the clean star. And you've used this before, whether you know it or not. If you are familiar with regular expressions, you definitely know what this is. If not, you will be familiar with regular expressions when you get to CISC 399. But what this means is 0 or more. Right? You've probably used this whenever you're in a file system and you want to get all the PDFs, right? You can do star.pdf. And the star, in that sense, means 0 or more of anything, 0 or more of any character, right? So in this situation, this is 0 or more method declarations. And this order can switch, by the way. In case you're interested, this is called EBNF or extended Bacchus-Naur form. I think it's spelled this way. It's odd spelling. Okay, Bacchus-Naur. You will see this in CISC 325 programming language paradigms. It is a way to generally express the structure of a statement without having to literally spell everything out. Okay? And you will see this from time to time in this class. Okay? You'll typically see it in this courier style font, this typewriter style font. I will, in my slideshows, try to keep code examples in this font. And when you see something like this, it is going to be expressing general structures. This will be the section of, this will be the module of the class where you see it the most, though. So, class, name, optional superclass, colon, constructor, methods. It seems a little minimal. Classes are super, super, super important and super complex. And so this seems 3 lines doesn't seem like much. Well, remember, constructor is going to expand out. Method declarations are going to expand out, and it's not just going to be one, it's going to be many. So you'll see how this works while still being fully accurate. Okay, so here's the first question I'm sure a lot of you are thinking. Where is the state stored? I've got a class, a name, a constructor, and method declarations. Right? Method declarations map to behaviors. But instance variables map to state. And I don't see any place to say instance variables. So where do we implement our instance variable design? Well, let's take a look at the constructor. The constructor constructs an object. It creates an object. It instantiates. It constructs an instance of an object. Instantiates. You'll hear those two terms used synonymously. Construction, instantiation. And it has the following format. Notice again, EBNF form. So we start with def and then 2 underscores. I'm going to put a red line here to show that this is a double underscore. INIT double underscore. And then a parenthesis, self, and then if our constructor takes any parameters, we'll put a comma, and then the list of parameters, just like we would do with a function. Remember, constructor is a type of method, a special type of method, and methods behave very similarly to functions. And then we can close off our parameters, put a colon, and then write the code that goes in the constructor. And any arbitrary code can go in there. But remember, the point of a constructor is to allocate memory and initialize the internal structure of an object. So the code that goes into our statements here could be anything, but it will almost always revolve around these 2 concepts, allocating memory and initializing the internal structure. That's the purpose of the constructor. So let's get existential. Let's get philosophical. What is self? Self is a keyword that refers to this newly created object. Okay? Self is a required parameter in the initializer. It must be used when referring to attributes or method of the object that you are currently in. Remember, we are going to be defining this behavior abstractly for the object. Dot append, right? List dot append, and we'll put 6 there. I don't care what list refers to. Append always does a very similar thing. It takes the parameter and puts it at the end of whatever list that list refers to. But that list could be an empty list. It could be a jagged 2D array. It could be a list with 500 different data points in it. It doesn't matter what it is. It still does the same thing. So when we are referring to any of the attributes or methods of this specific instance of our object within the class, self takes that place. And then you'll see later on in methods that self is also going to be there, and it's going to serve a similar purpose. But in the constructor, this is the thing that is being constructed. So when we call CC equals our credit card, right? And we'll see our self is going to end up being the value that's passed into CC. But then the question becomes, where is the structure of the object, of the state of the object defined? And the answer is in the constructor. Remember, this is what's allocating memory and initializing the internal structure of the object. So it goes in the constructor, and for those of you who want to be pedantic, this is technically the initializer. In Python, you'll hear it referred to as both. Okay, so I might call this the constructor or the initializer. For our purposes, it's the same thing. They're technically different things. But for our purposes, this is the constructor. So body statements of our constructor are their primary purpose and potentially sole purpose is to set up the object. And it includes things like setting up default values or saving any parameters passed in to instance variables. This is super crucial in object-oriented programming in Python because Python is an interpreted language. So variables only come into existence when they are executed in the interpreter. What this means is if we have a variable that isn't set up in our constructor, and then we have a method that calls on that variable that needs that data before that variable gets set up, program's going to crash. That is bad, obviously, because it can lead to program crashes. It's also highly coupled code. Right? The idea that I need to understand how this class is implemented internally in order to use it. Well, I need to construct the object, and then I need to make sure that this method never gets called before this method. That's bad. That is bad design, and you should not do that unless you've got a very, 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 very good reason. So this is how we define our constructor internally, and we already saw a clue of this. How do we use our constructor? We give a variable name. We say equals. We give a class name. We give parentheses. And we give our list of arguments. Right? This calls the constructor with the list of arguments. Okay? Whatever our arguments are, and I'm leaving it vague because we haven't defined that yet for our credit card. The one thing that you need to know is this. You will never, ever, ever pass in self as a argument. Okay? These are technically two different things, right? And these terms will get muddied sometimes. I will sometimes talk about parameters, and I will talk about arguments, and I will use them interchangeably. I try not to. But keep in mind, parameters are also known as formal parameters, and they are what are in your function or method definition. This is why this says parameter list. The actual values that you pass in, these are the arguments. Okay, so arguments become parameters, just like in a function. The only difference is, just like the self is required in our parameter list for a constructor, right? And it is a required aspect. That's part of what makes the machinery work. So we will have always one additional formal parameter above and beyond the argument list that you give. And the net result of this code is an object referenced by the variable, whatever this variable name is, with the state defined by the parameters and any default values that are given. For instance, if we call list and then give it an ordered triple, right, a three-piece tuple, it will take that tuple and it will create a list that contains those three values. And that will be the state of our list L. If we have another list, L2, here we'll call that L2 like that, and we say equals list, and we don't provide any parameters to it, any arguments to it. See, I did it just there. It will still set up the list, and it will contain the empty list, right? It will just default values so that this still gets set up. And we'll take a look at how to do that. So now we need to talk about methods. Once again, E, B, and F coming up. We define our method very similarly to a function. In fact, the only difference in the rules for method definition and function definition is self. Once again, all methods, the very first parameter must be self. And then after that, if you take any additional parameters, it'll be specified, as a standard list. So this is the structure for a method, which is designed to define a specific behavior of an object. Hopefully the name is very related to the behavior, but remember, the name only matters to humans. .append only means something to us. So if you name something append on the credit card and make it add $1 to the limit, okay, great, it works. It doesn't make any sense to humans. Computer doesn't care. Computer has no idea what append means, what the limit is, why that's important. So it defines a specific behavior of an object, hopefully related to the name of the method, and it operates like a function, including parameters and return values. Methods can and frequently do return things. Like I said, like with the dunder init, and that's you will frequently refer to methods that have this double underscore as dunder. Dunder init, it is the first parameter. Self is required as the first parameter, and this is how the interpreter understands that what you have defined is a method and not a function. Additionally, self represents the object that the method has been called on. So if you need to refer to another aspect of that specific object, you can use self, and that will refer to it. And you'll see how that works in a moment. So, as I said, methods. We tend to have a couple of broad classifications. So we're going to have different types of methods. The first one is called a getter. And because I come from a Java background, I will tell you that the other name for this is an accessor method. You'll hear me refer to either, right? Like the names imply, it gets some aspect of the state from the object, or it or it accesses. I put the emphasis on the wrong syllable, or it accesses things, right? It functionally, it returns some value from the object, but there might be light processing involved, right? For example, imagine an account object, which is designed to store the current state of accounts when people log into the server. So it might say something like 0, 1, 2, 3, 4, but those can be codes. Those are almost certainly codes. And 0 might mean not logged in, and 1 might mean logged in, and 2 might mean logged in as an admin, and 3 might be disabled, and 4 might be banned. So this is one of the reasons why you never access instance variables that are marked specifically as private. You never access any part of an object that is supposed to be private, is because the object controls that information, and it controls how you see that information. So if it wants you to see the code, there's going to be a getter that will let you get that code. Otherwise, it might know, hey, user's going to be using this. It doesn't give one damn about the code. So here's what this code means. If you were to access that code value and insert, overwrite it with like the value logged in, that's going to break the machinery, because the machinery is looking for a number and you've put in a string. But the user doesn't care about the number. It wants to know what that number means. So, lesson about poking at something that you're not supposed to. Getters are typically read-only. You don't typically see a getter altering the state of an object. Getters are usually used to literally just get some information. So then our next option is setters or mutators, right? Mutate, change. I will use both of these terms as well. And this sets some aspect of the state of the object. It mutates the object in some way. It might save a parameter into the state of the object. It might use that parameter to do a calculation. It might not take any information at all. It might just increment a value or decrement a value or double a value or reset a value to 0. Who knows? So a lot of the times setters save some parameter into the state, again, potentially with some light processing. These are typically write only, which is not a term. It is, but it's meant to represent the idea that these tend to alter some aspect of the object, but probably don't return anything. It can return something, and when it does, it usually returns some value that represents success or failure. So if you are doing if you have a mutator that resets the counter, it might return true or false. Did I succeed or did I fail? If you are, that's also very common for things like writing to a database. Hey, was the write able to be run, or were you unable to connect to the database? Other things that it might do. It could return a code, right? -1 is a failure, 0 is could not connect, 1 meant success. It could return the value that was written in as a kind of confirmation, right? Like when you get a confirmation number from someone, repeat it back to me, that sort of thing. Hey, update the spending limit to $22,000, and it returns 22,000. Beautiful. If it returns -1, that doesn't make any sense. You can't have a negative limit for a credit card. So that probably means it failed. So now the question becomes, Are there other types of methods? Are all methods either getters or setters? And the answer is no, all methods are not getters or setters. There are absolutely other types of methods. Not all methods fit cleanly into only one thing. Okay. Anytime in life someone says it's all this or that, that's a sign to immediately be skeptical. It doesn't mean it can't be true, but you need to interrogate the claim more. Now, having said that, many will be cleanly getters or setters. If you are doing a decent object-oriented design and programming implementation, I will tell you that you will have a lot of methods that are not cleanly getters or setters. But having said that, if you get done with your object implementation and you look at it and most of your methods are neither getters or setters, give your design another look. Just give it a look over and see, because it can happen. But in my experience, especially objects that tend to interact with interfaces a lot more, the vast majority of methods are getters or setters. You might give it another scan and go, no, this all makes sense. This is very well written code. It is not very highly coupled. It is highly cohesive. It does exactly what it needs to. It encapsulates everything it needs to. And then you go, great, that's perfect. Or you might realize, oh no, I have an object that is really doing three things, like three different jobs, and I need to refactor. Refactor means to redesign code in a way so that the outward behavior doesn't change. So I might need to refactor this object, this class, into three different classes. Who knows? But that's a little pro tip. When you're operating in a purely object-oriented paradigm, most of the time, your methods will mostly be getters and setters.